Hey everyone, welcome back to the channel. So today we are going to solve a problem that was asked on Accenture's 2024 September exam. This problem is based on distribution, and for solving distribution based problems we can opt for combinatorics or dynamic programming. In this video we will focus on dynamic programming. But for dynamic programming we have to write the recursion logic first. That will be the brute force. So what does the problem say? We are given a number of mangoes and number of persons. We need to find the total number of ways to distribute identical mangoes among identical persons. The input will be given in two lines. The first line represents the number of mangoes and the second line will represent the number of persons. We need to return the total number of ways. Okay, that will be the output. There were examples given. The first example was that we are given two mangoes and two persons, and the total possible ways were three. So how did we got to three? This can be shown with the example over here, as we can give each person one mango, or the first person with two mangoes and the second person with zero mangoes, or the first person with zero mangoes and the second person with two mangoes. Hence the total output will be 3. Another example, we are given total number of mangoes as 1 and total number of persons as 12. So how can we distribute that? We can see that we can give one mango to the first person and rest of the persons will have zero mangoes. Similarly, second person will have one mango and all the mangoes like 1, 3, 4, 5, they will have 0 mangoes. So this can be done in 12 ways where each person gets a mango in one of the possible cases. Now, to bring even more clarity over the problem, we will see another example. Suppose we are given 4 mangoes and 3 people. Then we need to find the total number of ways we can distribute the mangoes among the people. We will take 3 persons, 1, 2 and 3. Then how can we distribute the mangoes? We can give 4 mangoes to the first person, 0 mangoes to the second and 0 mangoes to the third one. This is a valid combination. After that, we can give 3 mangoes to the first person, 1 mango to second person and 0 mangoes to the third person. Now, another possibility is that we can give 3 mangoes to the first person, 0 mango to the second person and 1 mango to the third person. Another possibility is that we can give 2 mangoes to the first person, 2 mangoes to the second person and 0 mangoes to the third person, or 2 mangoes to the first person, 2 mangoes to the 0 mangoes to the second person and 2 mangoes to the third person. Another possibility, we can give 2 mangoes to the first person, 1 mango to the second person and 1 mango to the third person. Now, we can't do this. That is, give each member one mango, or we give each person one mango and we are left with some. that will be a invalid combination as we need to distribute all the mangoes. So 1, 1, 1 will be invalid. So this one is not valid. Till now, how many combinations did we got? We got 1, 2, 3, 4, 5, 6. 6 combinations. Now, again, another combinations. I'm just drawing the over here. First person, second person, third person. Now, over here, we gave the first person 4 mangoes. Now, we will give the first person 0 mangoes, second person 4 mangoes, and third person 0 mangoes. Again, we can give 1 mango to the first person, 3 mangoes to the second person, and 0 mangoes to the third person. Again, 0 mangoes to the first person, 3 mangoes to the second person, and 1 mangoes to the third person. Similarly, we can give mangoes to the first person, 2 mangoes to the second person, 0 mangoes to the third person, and 0 mangoes to the first person, 2 mangoes to the second person, and 0 mangoes to the third person. Sorry, mangoes to the third person. Also, we can give 1 mango to the first person, mangoes to the second person, and 1 mangoes to the third person. And this will again be the invalid case. Over here, we can see that 220 and 220 appears twice. Okay, so we won't be considering it 2 times. We will only be considering it 1 time. Okay, so till now, total number of ways are 1, over here 1, 2, 3, 4, 5, 6. And in this one, 7, 8, 9. This won't be considered. So 10 over here and 11. Now in the last combination, we will give the last combination. We will give all the mangoes first to the third person. Okay. So first person will get 0 mangoes, second person will get 0 mangoes, and third person will get 4 mangoes. Thirdly, first person will get 1 mango, second person will get 0 mango, third person will get 3 mangoes. Now again, first person will get 0 mangoes, second person will get 1 mango, and third person will get 3 mangoes. Another case is that for the first person will get 2 mangoes, second person will get 0 mangoes, third person will get 2 mangoes. And again, the first person will get 0 mangoes, the second person will get 2 mangoes, third person will get 2 mangoes. And lastly, the first person will get 1 mango, second person will get 1 mango, and third person will get 2 mangoes. And one of the invalid case again, 1, 1, 1. This is invalid as we have left with 1 mango. Okay, now we can see that over here this 0, 2 and this one occurring twice. So the total number of ways are now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Also, there will be 15 case, sorry. Since this 202 and over here we have 202. So total number of ways are 15. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Total number of ways. See, we have generated all the combinations over here. And to generate all the combinations, we can follow the brute force approach of recursion, in which we either take a element or not take it. But there is a catch in taking the element. See, over here, the persons can get 0 to 0 to n or 0 to m mangoes. Like first person over here gets 4, 3, 2, 2, 2, 2, 1, and 0. Rather, this is not a valid case. 0. So 0 to 3, 4. 0 to n mangoes. Okay. Now we will be implementing the recursive code. After that, we will see how we can memorize it to reduce the time complexity. Okay. So first of all, we need to take an input. That's the mandatory thing. So what we had to take? We had m number of mangoes and p number of persons. That is int m and int n. We need to take input in these two variables. Okay. For that, I will be using a scanner class. We are done with taking the inputs. We can close the scanner now. We will need to create a function for the recursion. Okay. So we will name the function as solve. It will be a static method. We have taken two arguments over here, int m for number of mangoes and int p for number of persons. So going to the base case, suppose we have 0 persons. Suppose p equals to 0 and m not equals to 0. That is, some mangoes are left. So this was not a valid case we have seen. So we would return 0. And if p equals to 0 and m is also equals to 0, that means we distributed all the mangoes. Then we return 1 as we have one possible combination. How to write the base case then? If p equals to 0 and after that again one if m equals to 0, then return 1, else return 0. See, this we can condense this thing like if p equals to 0, return m equals to 0. If m equals to 0, then return 1, else return 0. Okay, now going over the take and not take part for creating the combinations. Okay, so we have seen that either we give 0 mango to the person, to one of the person, or 1 mango or 2 mangoes up to m mangoes. So we need a for loop for that. For int I equals to m for number of mangoes, I greater than equals to 0, and I minus minus. Okay, what we need to calculate the number of ways. So we will create a variable int ways equals to 0. Now we need to calculate the total number of ways. For that, we need to call the function again and again for every person till 0 to m mangoes, as we can give either the person with 0 mangoes, 1 mangoes, 2 mangoes, 3 mangoes up to m mangoes. So we need to call the function solve m to p minus m to p. Suppose we have given m mangoes to a person, then the number of persons left will be reduced by 1, so p minus 1. Also, over here, i I is looping from m to 0. That is, first we are giving complete m mangoes to the person, then we are giving 1 less than m till 0 mangoes. So we can write over here m minus I. Now this will give the number of ways, so we need to store it also. So ways plus equals to solve, and then at last return ways. And now we need to call this function. So we need the result to be printed. So we are printing over here this out solve mn. Over here instead of n we should take p, okay, for that number of persons. Now we are going to run this, see if our logic is correct or not. Suppose we are giving 2 mangoes to 2 persons, then the total number of ways will be 3. It's working. Now again, if we have 1 mango and 12 persons, then the total number of ways will be 12. So we will check with the input that we have taken, that is the input of 4 mangoes and 3 people. Okay, so again running the program, we have 4 mangoes, we have 3 peoples, and according to a calculation there should be 15 total number of ways. See, we are getting 15 over here. Now what is the time complexity of this code? The time complexity of this code is m to the power of p. Why? Because we are distributing m mangoes to p persons. Also, for each person, we are giving 0 to m mangoes. So the time complexity is exponential. To improve this time complexity, we can use dynamic programming. But why should we use dynamic programming? Since we are calculating some results again and again, we can prune that, or we can use the pre-computed result. Okay, so to implement the dynamic programming, we need a way to store the results. And for that, over here, since these two parameters, m and p, both, these both are changing, so we need m cross p matrix. Okay, for that we are going to create a matrix, integer matrix, name it as dp, and its size should be m plus 1 and n plus 1. Why m plus 1 and n plus 1, or m plus 1 plus m plus 1 and p plus 1? Because for the last person, suppose we have 4 mangoes and 3 person. So in the array, we have zero based indexing. So for the last person, it will be as 3 and 2. So we will not be able to get the correct result. So to overcome that, we just extend one cell. Now we will pass this dp, change the method over here to accept dp array, or integer array, sorry, integer matrix. Name will be dp, and over here also. So before returning, we need to store the result. So where would we store the result? We will store the result in the dp matrix. Okay, dp of m, that is the number of mango, that is the mango, and p, person, equals to base. We'll store over here. Now after the base case, we will check if we have calculated the result previously. If so, then we will return it directly without further calculating it. That is, if dp of m p not equals to null. That means we have calculated the result previously. So just we need to return it. Return dp of m p. Now our memoized code is done. This was the time complexity for brute force. And for the memoized code, or dp, for dp, the time complexity will be, it will be the worst case m into p states. Okay, that is m cross p, or m into p. So we have reduced the time complexity vastly. This was exponential. So we need to check the results if our implemented code is working correctly or not. We will run it for 4 mangoes, 3 people. The result is 15. If you have any problem in understanding the solution, feel free to ask in the comments. And also, there is one more way to find the total number of ways, that is using combinatorics. If you want that video, please comment. I will make it. Thank you.